Welcome, my young Padawans, to Section 3-4, the Chain Rule, Part 2. First thing, don't forget about the chain rule. We're just going to be continuing to work with that the way that we did in the last section. And chain rule, again, is when you have the composition of two functions. So don't forget that you take the derivative of the bigger function and then multiply it by the derivative of that inside function, just like we had done in the last class. Let's take a look at a couple example problems next. The examples we look at today are going to deal primarily with our trig functions. So here's the first one. F of x is equal to the cosine of 3x minus 5. So the outside function, that big function, you should see is the cosine. And then the inside function is that 3x minus 5. So when I'm taking the derivative of cosine is negative sine. So let's hear f prime of x is going to equal negative sine of that 3x minus 5. So negative, the derivative of the cosine of Bob is negative sine of Bob times d Bob. And the derivative of 3x minus 5 is just 3. So when I rewrite out my function after I simplify it, do a little rearranging, I get negative 3 sine of 3x minus 5. Before we do number 2, I should mention that if at any point in this video you want to pause the video and try the problem out first, it's not a bad idea. That way you see whether you understand it or not. And of course, we'll always work through the solution. So at any point you can pause the video and try the problem out before I show you the answer. So number 2, we had g of x is equal to the tangent of the quantity x squared minus 3x. And again, we have the tangent of Bob. And the derivative of the tangent of Bob is the secant squared of Bob. And then we just have to remember to multiply by d Bob, which is that x squared minus 3x, the derivative of x squared minus 3x, which is 2x minus 3. Now, this would be fine. You could write it like this, but typically we'll write that polynomial part first, 2x minus 3, and then we'll write the secant squared of x squared minus 3x. Just the standard way we write things. It's not wrong the other way. This is just kind of a better way to write it. Let's try another example. And number 3, y is equal to 4 secant of 6 minus 5x. And if you remember, okay, so the derivative, y prime, that 4 is just going to be a constant, so we'll have that 4, and then we'll multiply by the derivative of the secant of 6 minus 5x. The derivative of secant of Bob would be secant Bob, tangent Bob. Oh, okay. So what this actually means is we'll write secant of 6 minus 5x, tangent of the same thing, 6 minus 5x. And then that is what we will multiply by the derivative of 6 minus 5x, which is just negative 5. And then if I do just a little bit of rearranging, I write my final answer. That's here. That's all multiplication, so I can do that 4 times that negative 5, get negative 20, secant of 6 minus 5x, tangent of 6 minus 5x. For this last example problem, I want to take a look at essentially the placement of an exponent, because I really have here with number 4, 3 different problems that all look, well, very close to each other. For A, I have y is equal to the cosine of 3x squared. I think it's important to note that it's the 3x squared is what we're taking the cosine of. And then in B, I have the cosine of 3x squared. Again, I think it's important to note that I'm taking the cosine of that quantity 3x squared. Dramatic pause included, or intentional there. And then for C, it's y is equal to cosine squared of 3x. I think it's worth noting that this is actually the cosine of 3x squared. Whenever you have cosine squared, that's actually what we mean. We mean we're taking that entire quantity of the cosine and squaring it. So we have 3 problems that are very similar, yet very different in the way that we're going to approach these. So for A, right, we have y prime equals, we have the cosine of Bob, and the derivative of the cosine of Bob is negative sine of Bob times d Bob. So we take the derivative of 3x squared, which is 6x. And again, we would rewrite that, just do a little rearranging, rewrite that as negative 6x sine of 3x squared. Pretty straightforward. What about for B? Well, let's hear B. We have the cosine of 3x, that quantity squared. So I have the cosine of Bob. And the derivative of the cosine of Bob is negative sine of Bob. Okay, I'll put that in the parentheses like that. Times, well, d Bob. Well, that's 3x, that quantity squared. Well, that's a chain rule. I got a quantity squared, so this is Bob squared. And the derivative of Bob squared is 2 times Bob to the first power times d Bob, the derivative of 3x, which is just 3. So now all I have to do is do some multiplication. I multiply some things together. Let's see here. I have the negative, I have the 2, the 3x, and the 3 all multiplied together. 3 times 3 is 9, times 2 is 18. So I get my answer of negative 18x times the sine of 3x squared. Okay, lastly, letter C. Let's give myself a little more room there. I have Bob squared. Okay, well, the derivative of Bob squared is 2 times Bob, the cosine of 3x, times d Bob. Well, the derivative of the cosine of 3x would be negative sine of 3x times, again, that d Bob. It's another chain rule in a chain rule. Ooh, chain rule in a chain rule. I got to be really careful of that. So I end up, when I simplify this down, it's all a big multiplication problem. So I have a 2 times 3 times that negative. So negative 6 cosine of 3x, sine of 3x. So 3 problems that look very similar, but the placement of that exponent changes everything. Sometimes we have to worry about a double chain rule, as we did in letter B and letter C. Or sometimes we don't have to worry about just a regular old chain rule like we did in part A. So I'm all finished here with this video. It's time for you to try some homework problems out. So take a look at those problems, and if you have any questions, let me know. Good luck.